Hello friends, welcome to Laptex. My name is Nasir and today I will demonstrate you a case study which I have been struggling for 2 hours and now to some extent I could be able to generate 3.3 and 5 volt. I will describe the entire situation in front of you and now you will guide me that what should be the next step. However, I have been always helping you, and our team Laptex is trying to help you out to understand the entire concept of laptop repairing and technique. But sometime it is also your responsibility to answer me on the comment box that what could be the possible reason of this problem. However, this is I think a first generation motherboard, but I would like to shed the light of this issue that generation doesn't matter with your technology, like the generation of 19 volt, the generation of 3.3 volt and 5 volt RAM regulation, and your core voltage and VCCP and VCCSA voltage. These voltages and concepts are almost same from the core to due to till generation. So let's go for that matter that what generation it is, but the concepts are always same in almost every architecture. So now the thing whatever I have done in this motherboard, first of all, let me introduce you the model number of this particular motherboard. This is the Dell motherboard and the part number is DV15CP. As a matter of fact, if I say you it is the first generation, you will think, okay, it might be easy because latest generation has the difficult issues. Not like that, because I have been working on the any generation, whether it is core to due or 10 generations, it doesn't matter. I need only think that if I want to check the signals, I am required IO information, like where there would be EC reset, where the VCC would be, where there would be communication of the BIOS, like chip select, like your clock, your data input and data output. These informations I look for. That is why I am required the pin configurations of that particular IO. So that is why you are unable to do most of the latest generation, because there is the unavailability of the schematic and the technical document. So in this motherboard, when I received, I found that there was no 3.3 volt and 5 volt. Now let me zoom it and I will show you the part number as well as the area where, as long as I have worked. So for last 2 hours, I have been struggling in this motherboard. Now, at that moment, I found the issue I will discuss with you. And really watch this video till the end. You will notice that you will learn something. And this is our motto to provide you the real knowledge of the electronics, especially in the laptop repairing. If you really want to enhance your technical knowledge in the laptop repairing, then you must contact on the given number and you can get the video courses from us. Now let me switch the camera and let me show you more clear pictures. So friends, as you can see that this is the model number of the motherboard DV15CP, and the problem I have also mentioned here for your convenience. Now you can see that these area I have worked, like while I was turning it on, this particular EC reset was having glitch. So I removed the glitch from the this EC reset pin after changing this NPN transistor. I will show you in the diagram. If you write Q3702, Q37 Q3702. So here was the problem. Reset, the EC reset, the most important signal which was having reset. And if you have noticed that in every video, whether it is in Hindi or English, I always recommend you must check this pin with the help of DSO, because your multimeter cannot identify the glitch on the particular signal. So if you forget or if you don't have DSO, you must get it as soon as possible and check this particular signal with the help of DSO in order to make it sure that it must have a DC straight line. So it was having glitch, and I have got this Q3702 was having problem, and now it was going to the pure hardware shutdown. This 3 volt was having problem. It was having a low voltage due to the that transistor was bad. If you copy this portion, you will find that where it is going. If this area is not having 3 volt, then the switching will go on this area, that all the voltage will go in this. So here we are not having voltage, the same voltage 1.2 I was getting on this point. The reduced voltage I was getting just because the diode is on, and the diode is on, and it will flow from this area to this area. Okay, so at that point, if you have less voltage or zero voltage, like you have zero voltage on this point, you cannot expect to have voltage on this point. This is the switching of the diode. If you really want to know that's how the diode switching works, and how the BJT works, how the transistor works, op amp works, so many components which are used in the motherboard, if you want to the depth knowledge, then you can join our video classes. So at this moment, I was getting this portion 3 volt, and on this 1.2 volt. On across the register, it was having 1.2 volt. Now I found that register that BJT was having problem, and I replaced that, and now I got the 3.3 volt. But still, I was not getting the entire situation absolutely fine, just because you can see that this area was having problem. You can see here, you can see that this is the cut mark. I have removed the EC on that. This is the 18 number pin of 51123 pin, and I just chop this area, and in order to find out that is there any problem in the this buck regulator, or the problem area is somewhere else. So I found that this area was absolutely fine. After cutting this area, despite I was having 1.2 volt, and I found that transistor was faulty. Now, I am discussing the case study as long as I have done. After this, you have to tell me that what should be the next. You must comment on the comment box of after watching this video. Now the situation is that you can see that I have tried to make a jumper wire from the 3 volt LDO to the enable. Now in that way I got the 3.3 and 5 volt, but still it was not turning on. Ultimately I found that these two, the charge pump diode was having problem, and I replaced this, and it was leakage, and I was not getting 15 volt the charge voltage which is required to be generated on this point, and it was the cause of the problem that that stopped turning on the board. The thing which was required, I have fulfilled all of those. Now you can see on the DSO, I am going to check it, that now I have 3.3. Let me inject the DC jack into the motherboard. Now you can see that this particular first, the area I have worked, I would like to show you the first area which I have done. This was the EC reset, and now you can see that there is no glitch at all. And as long as the load is concerned, you can see the load. As long as the load is concerned, you can see the load, that as soon as I inject the DC jack into the motherboard, you see that 0.56. I think it is a little bit more as much it is required, because in the always concept, like if the board is not in the suspend mode, it is having the always voltage, S5 voltage, then it must consume 0.35, not more to that. If it is having more to that, might be somewhere in the motherboard is shorting. So still I am not sure that there is a shorting anywhere, because if I show you this particular place, I am having 3.3 volt and 5 volt. This is the 5 volt I'm checking. It is available on the coil, and I'm checking 3 volt. It is also available on the coil. I am going to check the 15 volt, the charge pump voltage. So I'm going to check the charge pump voltage. So let me increase the voltage to check that voltage. 5 volt division I have set it. Now you can see that I'm getting the 5 around 13 to 15 volt I am getting on this point. So this was missing. That is why I changed this particular diode. It was having frequency because the Lgate frequency it is taking. Now you go on that 3.3 and 5 volt area, you will find out here. You go and type the D number, whatever the D number is. So D4604. So here is the charge pump concept, and it is nothing more than a concept that get a frequency and double the voltage by the help of this two capacitor. Now if you think that you are not having the 15 volt always, as soon as you are getting the 3.3 and 5 volt always, you must expect to have this particular voltage on the on this diode, like PD 4603 or any armature. You need to get this voltage. And here, sometime in some armature of the 3.3 and 5 volt, you will get that this particular frequency is coming out from the specific pin of that IC. Okay, that buck regulator. And in most of the time you will find in the Dell armature that it will get a frequency from the lower gate, as it is written power 3D3 volt Lgate 2. This is the same frequency which is required to generate the 3.3 voltage on the coil. The lower gate frequency is dedicated for the charge pump also. So you have to mind it here. The charge voltage must be present here, and the charge voltage and the voltage which is available here will produce the voltage as much capacitance value is present on this point. So the charge voltage plus the voltage which is available on the terminal will be generated on the other terminal. Like here you have given the 5 volt. Here you will find that the 10 volt around, and here the 10 volt will be charged. The 5 volt is the charging capacity of this capacitor, and now the 15 volt you will get on this point, like this way. So if I show you that do I get the charge point, so now I am going to check it. See this, pay attention on this. So I'm going to check this charge pump. Now you can see this is the charge pump. Okay, this is the charge pump, and here 5 volt plus charge pump is equal to more volt, like here 10 volt. Here the 10 volt. So this is the first diode, as you have seen on the schematic. This is the first diode, and here is the 5 volt. It has taken from the S5 voltage or the always voltage. Now you keep it here, and you will find on the DSO you see that 5 volt per division. Here the charge pump you will get. Okay, this is the charge pump, the charging frequency. It will add on in that voltage, and it will produce the more amount of voltage as you are getting in the internal point. Okay, so here the more voltage you are getting, around 10 volt you are getting, and the 10 volt here you will get here the 10 volt plus this charge. This is the capacitor charge. In order to achieve the charge voltage or the boost voltage, the most important role is played by capacitor. Okay, so because as long as the charge is concerned, the charge is inside the capacitor plus that voltage which was on the input terminal will be add on, and it will produce the maximum amount of voltage as much it is charged. So here is the concept of charge. It was unavailable, and I have replaced this two diode. You can see that the small diode I have got, you can see that this diode is required, the back-to-back diode is required. So I have replaced here. Now the situation is holding on this point, it is not turning on. So this was the scenario of entire motherboard I have discussed and I have described to you. Now the situation is that let me check it through the multimeter. all the required things I am getting. All the required things I am getting. Here 3 volt I have, here 5 volt I have, here the charge voltage I have, okay, 13 volt I have. On the on off switch I have 3.3 volt. Let's try to turn it on. However, in the Dell architecture, most of the time you will see or you will be experienced that in the Dell architecture, in the most of the architecture, you will find that without CMOS cell, the laptop turns on automatically. It is just because that AC percent overtaken the your power button on. That is why it is happen. So it must be turned on by itself, but it is not turning on. The thing I have done, EC reset was having glitch. I have removed that. 3.3 and 5 volt was unable to generate. I have generated the 3.3 and 5 volt. The charge pump voltage in order to generate the run voltage was missing. I have generated that voltage. What should I check now? You must comment that the thing which is required, like here, I think board is not turned on as of now, because I can say that SLP S4 is not generated. RSM reset. If you talk about the RSM reset, that those things which are required to generate, like here, let me show you the most important thing. You may answer this thing, that's RTC. So let me show you the RTC, that what is the condition of RTC signal. So here I am going to check the RTC. So you can see it has 32 kilohertz frequency. Your RTC is having 32 kilohertz frequency, and on the output, this was the input, this is the output. Now you can see that. So now we have checked that input and output of the RTC is absolutely fine. Now, should I replace the controller IO? Should I replace the PCH? Or what should I do? Need I to do the BIOS, like somewhere has already done the BIOS? If I give you a close look, you will find out that somebody has flushed the BIOS. But this is not hit and try case. If you want to confirm that whether the BIOS is okay or not. So for one example, I can show you without powering. Now keep it on the, because only matter is that you have to notice here that it it must have latch. There must be a latching between the IO and EC BIOS. Here is the EC BIOS, the pin number 1. I am keeping it, and let me turn on. You see that this is the big one, just because I have turned my X10 on. Now it is on the, and the voltage division I need to. So let me press auto. Now you can see that this is the latching between the EC BIOS a bit and your SIO chip. So this is absolutely fine. Now let me check the clock. So it is having clock also. Now data input and data output all are absolutely fine. Now what's next? You must comment on the comment box, and inshallah in the next video I will give you the solution that how should you begin with a laptop which is not turning on. You should not skip that part, otherwise you are gonna lose the motherboard. You cannot repair that motherboard. If you have no more experience in the field of laptop repairing, then hopefully that if you receive these types of problem, because you can see that I have received this motherboard from the technician from the other state, and I have to do it the same way. If you receive the motherboard from the other technician, if somebody has worked before you, then it may be hard not to crack to solve the issue. So if you really like this video, please hit the like button. And if you have been constantly watching our video and you haven't subscribed as of now, please subscribe it. That would be very admirable for us. And if it is possible to share the video for the sake of those who is really needy, who is seeking for the help, you must share it in your comment group. See you in the next video with the solution of this case study. Thank you guys. Thank you for watching this video.